To try to dig them down, you have to read them, you have to understand, you have to incorporate these terminologies with examples in such a way that you are not looking for the marks, but you are looking for understanding. You are not looking for thinking inside the box, you have to think outside the box. And you have to learn them in such a way that there is a problem that I have to solve it today. And only that problem is that you just need to understand this terminology. Are we together? Otherwise, you say, one day I will learn them. So one day I'll learn them. So the first one is called schematic circuit diagram. Say schematic circuit diagram.
Schematic circuit diagram.
So schematic circuit diagrams, this is the common and useful terminology in electronics, especially in practical, more than you think. Because now this one, it's the next phase after block diagram. Alright? However, that in secondary education we have been taught about schematic diagram. Maybe we haven't heard anything about block diagram, but now we are preparing you to be an engineer. There's no way out that we can teach you in shortcut. We have to teach you in process and actually have to think, because we believe that you have something that you can do and there is a problem waiting for you to solve in engineering. And nobody who can solve rather than you. So it's a matter of yourself to know. It's a matter of yourself to get prepared. Right?
Yes.
But if you'll be that if you have a mindset that all the problems have been solved by Europeans or Americans, okay. So why did you come from in this world? You have to die. Because people who are still alive here, they have to solve, there's a particular problems or they have an assignment to do. Once you finish, you have to go. Yes. Are you ready to go? No. You are not ready. Are you ready to solve a problem? You are not ready. So actually, you are confusing God. And you are confusing us. Are you ready to die? No. What problems are you solving? I don't know yet. Until I finish the university. Once you finish, I will get a work somewhere. Okay. So the first is schematic circuit diagram or schematic diagram. Say schematic diagram.
Schematic diagram.
So now the schematic diagrams, it's a analysis or it's a detail of the block diagram. So the block diagrams, it's the input of the good schematic circuit diagram. Are we together?
Yes.
Okay, are we together?
Yes.
Then number 10 is implementation electronics. So once we know the schematic diagram, now we can implement the circuit. Right? Implementation is actual building up of what you have been thinking about. Are we together?
Yes.
Then the 11th is data sheet. Say data sheet.
Data sheet.
Data sheet is the very important terminology in electronics, more than you think. And many engineers and technicians, they do ignore it. And because they do ignore it, you find the designs or the implementations of the circuit will never work. Why? Because what the manufacturer has designed is not yet in the mind of the designer or implementer. Why? Because data sheets are being written and designed by the manufacturers. Are we together? Are being designed and published by manufacturers. You cannot sell electronics components without writing a data sheet. Because you're a manufacturer, maybe you're in the United States or you're in China, you cannot go over the world to explain people about what you have made. Are we together?
Yes.
Are we together? Are we together?
Yes.
That's the overview. So it means that you have to learn it and you have to find examples, because before you use a particular component, you should know the manufacturer's mind. Right?
Yes.
You have never made a transistor. Transistor has been made by a manufacturer. So once you meet that transistor, it's better to go through the mind of the manufacturer. Where will you find the mind of the manufacturer? You'll find the mind of the manufacturer in Dotty. And you'll find technical. Then we have user manual or instructional manual. So user manual, actually in the big picture, this is it's a small book or it's instructional manual or instructional guidance that the manufacturer used to provide with a particular product. And actually explain to you how you can operate that manual. Are we together? So define them, what is it? So just explain them briefly, and then provide examples. You can go through the data sheet, you can download them, and then you can enjoy them, start enjoying them. Because later on say, okay, I want the data sheet of what a regulator LM, maybe 708005. So you understand data sheet, what the means of data sheet. Are we together?
Yes.
But also you avoid accident of burning out the components or destroying the components without achieving the goals of your design. Are we together?
Yes.
Okay, up to this point, is there any question? Hilda has a question. You're welcome. Do you have any question about block diagram? Did you understand?
Yes.
Did it change you?
Yes.
Sure.
Yes.
So what will you make on it? Will you draw in block diagrams? Okay, in this local class and even online students, who can give me a promise that from now onwards, in a single day, 24 hours, I will draw at least one block diagram for the electronic system? Raise up your hand.
For any electronic system.
For electronic system, it means you have a strategy. That I will be studying different T system, because you can draw the block diagrams by studying different T system, right? For example, the mobile phone. So you can even write that, okay, so I have input, whatever, and then you come, the input contains this and this and this. But also you can think about something, how does it work, and then so you draw its block diagrams, maybe in this style or this style. So I want to know students who will be ready at least a single day. Spend maybe 30 minutes to draw a block diagrams of a particular system. Every day. Raise up your hand. Wow. So the whole class raised up your hand.
Yes.
So from tomorrow I can assess.
Yes.
Or should I start next Monday? Because always students will ask you, start next Monday, because today tomorrow is Tuesday, sir. Starting on Tuesday it's difficult. Monday it's a good starting day. So will you make it?
Yes.
I'm happy to hear about that. And you should not worry about making mistakes. We learn through mistakes. We don't like to do mistakes, but learning through mistakes is powerful more than learning without doing mistakes. So don't expect for you to be perfect 100%. You can do something, you do a mistake, somebody, and you know that people, they have different ways of interpreting mistakes. But for yourself, take that this is the advantage to learn, so that I cannot repeat the same mistake, and I have to learn from it, so that I will be careful and I understand the particular concept. So when you'll be doing such kind of the practice, you should not worry about doing mistake. Try your level best as well as you do, you'll be correcting. Most of the mistake you'll be correcting yourself. Because you'll be reasoning, why this is not working? Why this is like this one? Why this like this one? So through reasoning, you get answers of the questions. Are we together?
Yes.
Are we together? So our assessment for the block dance will start tomorrow. Don't give me politics that I went it, there's no electric power, power went off, and you know that you don't have a generator there. So I found myself, I fall asleep. That's not good. Okay, welcome. Gil, you have a question?
Yes.
Welcome.
I wanted to ask that, are we going to take different circuits which you are doing them, then creating a block diagram, or creating our own circuit, then labeling them?
Whatever you can do. Yeah. I don't want to limit you. Whether the one you learned in the class, but you learned it blindly, you are given your group member a companion and a teacher that you were there, but actually didn't understand what you are doing. So now you can go and restudy them afresh. Or maybe you have a television set, then you start thinking, what are the inputs of this television set? You didn't open it yet inside of it, but you are trying to think about how does it operate. You can think on the side of operation, just like the smartphone. You didn't open the smartphones and see the motherboard, but how does it operate, right? Because the information which is being taken, it's the one that which is being processed. Are we together?
Yes.
Did you hear the questions of Gil?
Yes.
And you? Do you have a questions? Okay, Nancy, welcome. You have any question? No, there's no in this class. So at least I found those 12 technologies for you. Once you understand them, it doesn't mean that those are all the technologies that you have to know in electronics. but at least they can position you in a very interesting technical environment.
Sir,
Yes.
what is the difference between a power signal and the information signal?
Okay, what the difference between power signal and information signal? Okay, here it's a difference. There are so many differences, but I'll mention one which is common. The power signal, actually, it's a line, or it's a wire, or it's a copper mat, or it's a conductor that conducting power from the power bank to the particular place where that power is required to be used in operations of that part. Right? The information signal is also carrying power because it can be in electrical form. Right? But now, that once we call it information signal because once it has been processed, it gives us a particular information. For example, if I have a smartphone's battery, that battery will be providing the power signal. Right? For example, for the turning on the microphone. But microphone is powered, right? In order for it to work, it needs power. Power is there, right? But what the function of the microphone? To pick up the sound or the voice, right? So it means that I have to give a microphone the information signal or the data signal. And the data signal, it means that, okay, I have to produce a particular sound. And in most cases, it should be meaningful. It should have a particular message. Even if I'm crying, once you listen, maybe I'm crying through my handset and I called you, then you get the information that Olenjolai is crying. Right? But the power signal, for example, if you power the speaker, you power the microphone, then the microphone and the speaker, they cannot hear just crying. Why? Because that is power signal. It's just like if, for example, if you power a speaker, it cannot produce itself the sound. Have you ever experienced that?
No.
No. If you don't give it the input, then it's waiting for you. Are we together? Yeah. First of all, that's a good question. Clap your hand for him. Okay. 1, 2, 3. So that's the difference between information, and you should not forget that as an electronics engineer. Are we together? Remember, even in television, say that you are watching at your home. Maybe you're watching the football, the Yanga, or maybe the Simba, or whatever. Maybe, regardless, or maybe you are watching, for example, the movies in Azam TV, right? So there is a power signal and information signal. And once you go into television set, because I've opened it, you find even the cables have been arranged that this is the cable for power signal and this is the cable for data signal. Once you mix them, or you mix up, or maybe once you'll be troubleshooting, you have to know what are the common problems that encountering the power cables, and what are the common problems that encountering the information cables. From there, it simplifies your troubleshooting. Are we together? So similar, at least for the television set, once you open, you see some cables, some wires. But for the smartphone, there's no wires, but there are the copper lines. And the copper lines are just like the one that I've been showing you in this variable. So these copper lines are representing wires or cables. Are we together? Okay. So if you have any question, don't hesitate to ask me. And doesn't mean that I know every answer or the answer of every question of yours, but I will try my level best. Is there any other question? Nancy, do you have any question? Promise. She said that I have another question. I like questions. You're welcome.
Sir, every circuit ambayo nakutana nayo inakuwa lazima inakuwa na hizo input power na subsystem na output. Lakini hamna components nikiziona tutajua hii ni input unit.
Sijaelewa swali lako. Kwanza umeanza kusema kama unataka kukanusha. Right? You are asking that, do you mean that every circuit that you meet have those parts? That's your first question, isn't it? And the second question?
Hamna components ambazo ni common. Yaani nikiona kama ni sensor najua hii ni input. Nikiona kama ni voltage najua ni power supply. Nikiona output najua hichi ni output.
Yes, as long as you'll be learning electronics from day to day, you will be identifying common inputting components. For example, the microphone. The microphone will never be an output unit. The microphone will never be a processor. Right? The microphone will never be a power supply unit. So it's always the input unit. You understand? You understand? Okay, resistor, it can be either an input unity, maybe it can be in processing unity, a resistor can be used in output unity, can be used in power supply unity. So you should not claim. Some of the parts, some of the components are always functions at the input, just like even the parts of your human body. Have you ever found that the eye is an output?
Yeah.
Huh? Have you ever found that the human eye is an output? Huh? Huh? For example, that you are angry, can you beat me by using your eye?
No.
No. Huh? Huh?
Lakini inaakti kama output.
How?
Inatoa machozi.
No, so there you are talking about something else. It's not an eye, so something else. Because once you are crying, something is coming out through your eyes. That's the additional. Huh? The only input and output is our mouth, right? Huh? It's an input and what? So it's my purpose. Huh?
But silent eye sometimes can act as an eye.
Okay, in most cases, have you ever found an human, for example, an ear to be an output?
No.
Huh?
For
It can
animals.
give something else, but that is in case it's not working. It's abnormal. I'm not talking about abnormal. For example, an ear which is working perfectly. Have you ever found that giving you the information from the brain?
Maybe for animals, like dog. He moves his ear in different seasons. For example, when he's sad, or he knows there's something, he gives you an output maybe by folding his ear. Maybe I'm hungry. When there are too much.
But no, that is human study. But sometimes it does not mean like that.
It's human stuff.
Yes, it's human study. Maybe if your dog is actually folding the ear, it means that the dog is hungry or whatever. That is human study. Right?
Yes.
But let me ask you, have you ever produced something on your ear? Or maybe have you ever talked on your ear by using your ear? Have you ever talked by using your ear?
No.
No. So an ear, it's an what?
Input.
In most cases.
Yes.
Right?
Yes.
Unless something else that has to be added as other features. Are we together? Yeah, so that is the answer. But again, it's concerned about you. Do you mean that all the electronic system contain this? Yes, I say most electronic system, they contain these 4 blocks. If they are not communication system. Most of them. Whether small, whether simple, or intermediate, or complex. But sometimes it's difficult for you to identify these 4 blocks until you sit down and study together. You know that to draw these 4 blocks is simple, but now once you've been given a circuit to study and understand that this is whatever, this is the input, especially if you be given a schematic, don't think that it's an easy business. You have to understand. But once you understand, most stuff becomes easy. Are we together? Yeah. Okay. So if that's the case, I'd like to say that at the end of workshop 2, so get prepared for the workshop 3.